I'm Flora Giesbrecht. I'm the watershed coordinator for the Elbow River Watershed Partnership.
My name is Joe Fowler. I work as an environmental educator with ERWP.
Not to be cheeky, but groundwater is water underground that exists in the pores and spaces, cracks and fissures. So it comes from the surface in the form of rain and snow.
When we think of a river, we often think about what we can see, but it's really important to remember that this space around the river is also saturated with water as well. There's a whole underground river that we can't really see at all.
It starts in the headwaters, basically.
And then when we experience our seasonal high waters, it kind of recharges those groundwater levels. So we might see that water table rise quite a bit, and then the groundwater or the ground itself is sort of acting like a sponge, and it's absorbing all of that water.
So there's two different types of aquifers, consolidated and unconsolidated. So a consolidated aquifer consists of a layer of rock, and then underneath it would be some cracks and pores and water that's accessible in those pores that you can draw from. Above the consolidated layer would be gravels, silts, and clay, and the water that exists in those pores would be in the unconsolidated aquifers. And most of the groundwater that we access in the Elbow watershed is shallow.
So anytime it snows, when that snow melts or when it rains, that water is touching all areas of the landscape, and it's slowly moving down to the lowest points in the landscape, which is where we find our larger bodies of water. We often find phosphates and detergents and soaps. So what is the impact of having a large municipality adding those soaps and detergents to our water system? Roads are quite hard packed, so that water, rather than being absorbed by the ground, it's going to kind of quickly rush off that road. And you also have to remember that storm drains go right through our rivers.
It's very common to have rural residences in the Elbow watersheds. A lot of those homes have septic fields and septic tanks. And so there's an assumption that the ground itself is a filter. In reality, there can be things that happen where some of that waste can enter the groundwater, and if it's shallow and there's a creek nearby, it's more likely to enter the creek. We do know how much water we use as groundwater in Alberta, so approximately 21% of the water used is groundwater in Alberta. In the Elbow watershed, most of the groundwater is used for residential, the shallow groundwater wells. So this aquifer, it's quite wide and deep. So there's some areas where it's up to 2 kilometers wide and up to 20 meters deep. It contributes to the base flow of the river. So especially in the summer season, most of the snow is melted, so the river that we see flowing is mostly base flow, groundwater.
The river is an expression of the landscape, so everything that's happening on the land can show up in our water quality in some way. And these aquifers are kind of like a natural insurance policy. They do protect our municipalities from the impacts of flood and drought. If we don't have an aquifer for that water to go into, it's going to flood our municipalities. All that water is going to quickly go downstream. If we give that water a place to go, then it's not going to hit our communities as hard.
To have a healthy aquifer, we also need a healthy watershed. So the headwaters in particular, they need protection, and wetlands and the tributaries and all the little creeks that flow into the river, they feed the aquifer.
It's important to remember that water is the greatest solvent. It's very, very easy to add to water systems, and it can be super hard to take things out. Small actions, they do have a really, really big impact.
It's not just one industry or one action or one land use.
We are so close to our headwaters, so we have access to some of the cleanest drinking water in the world. And it's important to remember that everything we do here, it impacts that water as it flows downstream throughout the prairie provinces.
The actual amount of accessible fresh water is very, very small.
I think it's 97% of it is salt water.
Right.
And then of the 3% of fresh water we have, most of it is frozen, about 30% of it is trapped underground, so only about 1% of it is that accessible surface water where we see that fresh water that we all need to stay alive is actually quite precious.